Good day, grade 12 learners. Welcome to today's physical science lesson. My name is Mashudu Mamburu. This lesson is brought to you by the Gauteng Department of Education in collaboration with the Saibono Discovery Center. As I indicated, Mashudu Mamburu is my name. We'll be focusing on paper 2, revision. I hope you're going to enjoy. Remember, paper 2 is still 150 marks, but our most focus will be on question 7, which is your acids and bases. Remember, you've done this topic at the end of term 2. You didn't have much time for revision and all that, so we're hoping that after this lesson, you will have revised this topic. You will be more comfortable with it. So what we have done, we have taken question papers from other provinces. Remember, you were writing your prelim exams. So we've taken question papers, some the whole question paper, some part of the question paper. We've taken them, we put them together so that we can go through them and do questions. So today is not more about teaching, but it's about problem solving and strategies as to how do you go about solving problems here. We'll do some stoichiometry because we are realizing that the learners are losing a lot of marks when it comes to those kind of calculations. So we're hoping that this lesson will be of great help to you and will make you more confident with this topic. Remember, acids and bases, we always start with the Arenas model, which is our definition of an acid and a base according to Arenas. Remember, we said an acid is a proton donor. That is a hydrogen ion, it's a substance that produces hydrogen ion in aqueous solution. So an acid produces hydrogen ion in aqueous solution. So when you put an acid in water, it will produce hydrogen ion, then it will form hydronium ion. So that's how Arenas defined an acid. He said it's a substance that produces hydrogen ion in aqueous solution. So please be able to write that it produces hydrogen ion in aqueous solution. And he defined a base as a substance that produces hydroxide ion, OH minus. It produces hydroxide ion in aqueous solution. So we're saying when you put your base in water, it will produce OH minus. So these two are very much important. Remember, in your exam guideline, you can write hydrogen ion like that. You can write it in full, and then you can say it produces hydronium ion, because remember that hydrogen ion can react with water and form hydronium ion. So you got to have that understanding. So an acid, obviously, for it to produce hydrogen ion, we are saying that an acid must have a hydrogen ion so that when you put it in aqueous solution, it can be able to produce it. So that is the first thing that we're talking, Arenas model, how acid and base are defined. The second thing is the same definition in terms of Lorentz-Bronsted now, because Lorentz-Bronsted is talking now about a proton. Remember, our proton, we are still referring to our hydrogen ion. So he said an acid is a proton donor. It's a proton donor, and the base is a proton acceptor. So with Lorentz-Bronsted, we are referring to the proton to say the other one, the acid will donate a proton and the base will accept the proton. So that will be the difference between the Arenas. You can see the proton is there, but we are calling it hydrogen ion here to say an acid produces hydrogen ion in aqueous solution and the base produces hydroxide ion in aqueous solution. But now when it comes to Lorentz-Bronsted, we're saying an acid is a proton donor, donate it, and then a base is a proton acceptor. So the difference is that a base will accept a proton while an acid will donate that proton. I hope you get that. And then the other thing which is important is that these acids, they can be classified as being strong or weak. So when you talk about an acid, there's an acid that is classified as being a strong acid. Usually when you talk about strong acids, our normal ones that comes to your mind would be your HCl, your H2SO4, and your nitric acid. So those would be your normal acids that we refer to them as being strong acids. So these are the common strong acids that we have, which is hydrochloric acid, sulfuric acid, and nitric acid. So you must know them and know how to write them as expected by your exam guidelines. So these are strong acid. And by definition, we're saying a strong acid, they ionize completely in aqueous solution or in water. They ionizes completely in water to form high concentration of hydronium ion. So we're saying all these three, because they are strong acid, they will ionize completely. So it means when you put them in water, they will ionize completely and form high concentration of hydronium ion. Whereas now, when you talk about weak acids, so when you talk about the weak acid, we're talking about your hydrogen fluoride, your HF, we're talking many of those, your carbonic acid, H2CO3, we're talking your phosphoric acid, H3PO4. These are your some of the examples of your weak acids that we are having. And these ones we are saying they ionize incompletely in water. And because they ionize incompletely, it means they form a low concentration of hydronium ion. So the expectation is that we'll have a low concentration of hydronium ion when it comes to the weak acids. I just gave you some of them. These are the weak acids. And remember, we're saying all organic acids, they are weak acids. So organic acid here, we're talking about oxalic acid, which, for example, is written as COOH with a 2 there. That is oxalic acid, so an organic acid. Another organic acid that we're having is ethanoic acid, which is CH3COOH. And we're saying all these organic acids, they are weak acids. So you will classify these ones as your weak acids. So the difference is how they ionize. So we're saying the strong ones, they will always ionize completely and they form high concentration of H3O plus. The weak ones, they ionize incompletely and they form a low concentration of hydronium ion. I hope that helps you. And then we go to the weak strong base and the weak base. For base now, we're saying for a base to be strong, it means it must dissociate. The base dissociate. You can see the difference in the language, but we don't necessarily penalize you for interchanging the use of ionize and dissociate. But in real essence, a base dissociates and an acid ionizes. So that difference, it can help you when you deal with your definitions. So we're saying a strong base will dissociate completely in water and it will form high concentration of hydroxide ion. So it's important to always know that if it dissociates or ionizes completely, it must form high concentration. And then the weak base will dissociate completely in water to form a low concentration of hydroxide ion. So it's important that you know those differences between a strong acid and a weak acid. I always ask learners a question to say if you are having a strong acid, let's say you take HCl for example, and you put it in a lot of water, you react it with water, and then will it become weak? Because the misconception that learners have is that if you take a strong acid, you put it in water, then too much water, and then that it becomes weak. No, a strong acid remains a strong acid. As long as it's HCl, you know that it's a strong acid. However, the difference now is that it can be dilute or concentrated. So when we say, because by definition we're saying concentration is N over V. So when you say define concentrated, you got to say concentrated means the large number of moles in proportion to the volume of water. That's how you define concentrated. You're saying it's a large number of moles in proportion to the volume of water. And you have to know the definition as well of dilute. So dilute will mean the difference of that, which in this case will be lower number of moles or less number of moles in proportion to the volume of water. It means there is more water added unto it, then it makes it dilute. Remember, I said when you pour water, it doesn't mean that it becomes weak. A strong acid remains strong acid irrespective of the amount of water that is added on it. So it's very much important. I've seen another question that gave learners 0.1 moles per cubic decimeter of sulfuric acid. And then the question was, is this acid strong or weak? Is this acid dilute or concentrated? Remember, that 0.1 is N over V. Remember, concentration is number of moles per unit volume of the solvent. So in this case, it means we had one number of moles, 1 over 10. So which means we had less number of moles of an acid, of sulfuric acid. It was less number of moles in proportion to the volume of water. So there is more water added on it. So the answer would be that acid, because it's 0.1, it has been diluted. So it's very much important that you have that understanding of saying a strong acid remains a strong acid, a strong base remains a strong base, irrespective of the amount of water that has been added to it. However, when you add too much water, when you are diluting a strong acid. So we now call it a dilute strong acid. Still an acid, but it has been diluted, and the word dilute is saying there is less number of moles in proportion to the volume of water. I hope now you understand what is a strong acid, what is a weak acid, what is a strong base, what is a weak base, and you know the meaning of the word dilute and concentrated in terms of this formula of C equals to N over V. I hope you will always remember that and have that in mind, because we'll ask you questions related to that. Now, the other thing that is important is the issue of conjugate acid base pairs. Conjugate acid base pairs. It's important that you are able to understand. Let's say, for example, we put your HCl, which is a strong acid, we put it in water, and then it forms H3O plus. It forms H3O plus chlorine minus in that fashion, in that manner. So when you say find the conjugate, the relative. So you are looking for what looks like a look-alike. So obviously you can't say HCl looks like H3O plus, but you can say HCl looks like Cl minus. However, there's a difference of one hydrogen ion. So you can see that the acid now has more hydrogen ion as compared to the conjugate base. So we'll call HCl is an acid, and the chlorine minus is a conjugate base, and the difference between them is just the hydrogen ion there. Now, if you look, we're having H2O, which is hydrogen deficient, or which has less hydrogens as compared to H3O plus. So these two are conjugates. So we'll say this, because it's on the left, you would always have an acid reacting with a base. So on the left, you have an acid reacting with a base. On the right, you have a conjugate acid plus a conjugate base. I hope you understand that the issue of conjugate acid base pairs, so that all the time you are looking for relatives. You are looking for those that looks like one another. In this case, we are saying HCl is an acid, its conjugate base will be Cl minus, and the difference is a hydrogen ion, because according to Arrhenius, he said an acid must be able to produce hydrogen ion. So you can see the HCl produces hydrogen ion, which is accepted by a base, because he said according to according to Laurie-Bronsted, we said a base is a proton acceptor, so it's able to accept a proton that is being donated by the hydrogen, by the HCl there, and then it becomes H2O plus. So I hope if I reflect, you know what we have done. We're saying you know the definition according to Arrhenius of both an acid and a base. You know a definition according to Laurie-Bronsted. He said an acid is a proton donor, a base is a proton acceptor. You know what is a strong acid, that it ionizes completely in aqueous solution to form high concentration of hydronium ion, but a weak acid will ionize in completely in aqueous solution to form low concentration of hydronium ion. We said a weak acid will ionize in completely in water or in aqueous solution to form low concentration of hydronium ion. So it's important that you always talk about what is being formed. So you can't just say a strong acid ionizes completely in water or in aqueous solution. You must say to form a high concentration of hydronium ion. So I hope I've emphasized that. I've emphasized the issue of concentrated versus dilute. So when you say concentrated, you go back to this formula and say it means we have large number of moles in proportion to the volume of water that is concentrated. And when we say dilute, we're saying we have less number of moles in proportion to the volume of water. And we said dilute, if you're getting something that says 0, something, you know already that must be diluted, because it means we have a less number of moles in proportion to the volume of water. So we have more water than the number of moles of a substance. So I hope that helps us. We talked to the issue of an acid and a base, conjugate base pairs. We said on the left of the acid-base reaction, we have an acid reacting with a base to form a conjugate acid and conjugate base. And you are looking for relatives to say HCl look-alike, chlorine minus. So HCl is an acid, Cl minus will be a conjugate base. H2O, it has accepted a proton, so it is a base. And then H3O plus will be a conjugate acid. I hope we move together in terms of that. This is your summary of this topic, so that when we start doing questions, you are able to relate to everything that I'm talking to here. Now, the process called hydrolysis. Now, hydrolysis is a process we're saying here is the reaction of a salt with water. So you'll be given a salt. When you react it with water, if it undergoes hydrolysis, we're expecting the pH to change there. We're expecting that it will either become acidic or basic. However, the salts of strong acid and strong base, your sodium chloride, which are formed from sodium hydroxide plus HCl, that salt will be a neutral salt. So it means when you put it in water, it won't hydrolyze. So you got to understand that a salt of a strong acid and a strong base does not undergo hydrolysis. So you'll be doing questions. You got to always remember that when you see a salt, you must say, where is this salt coming from? If it's a salt of a strong acid and a weak base, a strong one always win. The salt will be acidic. Then you know that the pH will be less than 7. So it's important that we have that. And then we will look at some neutralization reactions. In this case, under neutralization, we are saying you are given a nice formula, the CAVA, or usually refer to it as that, just for you to remember CAVA, which is CAVA equals to NaCbVb Na over Nb. That is the formula that we use for our titration, for our neutralization. So you got to know that formula and know how to use it. Remember, during titration, we are saying we are having now two concentrations. And we are saying now the concentration of an acid and the concentration of the base. Because we are reacting an acid and the base, they are undergoing neutralization. Hence, we are saying neutralization is a reaction between an acid and a base to form salt and water. That is neutralization. If I might say it in a slow way, we're saying neutralization is a reaction of an acid and a base to form salt and water. Remember what is hydrolysis? We said it's a reaction between the reaction of salt with water. We call it hydrolysis, which are the products of neutralization. So I hope you got that. And lastly, we're going to look at these titration calculations that I talked about, this formula, and then we're going to look at stoichiometric calculations. And if you look at majority of provinces, if you look at the question papers that we're going to look at, you will see that there are many questions that are now based on stoichiometry. So it's important that we know how to do these calculations. And the pH calculation, the issue of the pH scale. Remember, we're saying our pH scale, it runs from 0 to 14. So 0 to 14, that is our pH scale. And we know that anything less than 7 is acidic. But the strength of an acid is to the left, which means that anything 1, 2, we're talking about strong acids. But towards 7 there, when you go to the right, towards 7, you are getting weak acids. So we have weak acid, which is close to 7. That's where you will find your weak acids that we talked about, your hydrogen fluoride, your carbonic acid. They are weak acids, so you'll get them there around 6, pH of 5, 6, around there. The strong acid, your HCl, you'll get them around the pH of 1, the pH of 2, and then your sulfuric acid, your nitric acid, because those are strong acids. So strong acid, they have a lower pH, but the weak acid, their pH is closer to 7. And then anything more than 7. Remember at 7, we're saying neutral. Neutral, you can have a salt that is formed from a strong acid and a strong base. Definitely, that salt will become neutral. Hence, the pH will be 7. But anything more than 7 is where we find the base now. So strong base is far right. So towards 14, that's where you are expecting lithium hydroxide, sodium hydroxide, and potassium hydroxide, because those are common strong bases that we are having. But your weak base, your carbonates, your calcium carbonate, sodium carbonates, and all that, they are closer to 7. So they'll be around 7, something, around 8 there. Around, you know that those are weak bases. So anything close to 7 is weak, either to the right or to the left. But to the ends, we are having strong base towards 14, we are having strong acid towards 0 there. You know that those are strong acids and strong bases respectively. So I hope this summary helps us, or it has laid a foundation for us to start doing questions, because as I indicated that we're going to focus more on dealing with questions, how to go about answering questions, and I'm hoping that this lesson will help you and you'll be more comfortable dealing with questions in this topic. Now, without any wasting of time, let's go. We'll start with the question paper written in Free State now in September during the prelim exam. And then we'll do this question paper. We'll go, I think we'll do about 6 question papers. So we'll be moving, but I will try to make sure that you understand me. We'll move together. Some of the questions I might give you few minutes for you to do them so that you get a feel of how to go about answering the questions. I'm hoping you have your pen, you have your calculator, so that you are able to do some of these calculations that we're going to come across here. Now, the statement says, according to the balance equation below, a dilute, already when you see the word dilute, you remember that it has less number of moles in proportion to the volume of water. A dilute solution of hydrochloric acid. When you see hydrochloric acid, you see a strong acid. It's titrated against ammonia. Ammonia is a weak base. So we're having a strong acid reacting with a weak base. And then you know what happens. We form a salt there. The salt that is being formed there is called ammonium chloride. And the first thing that will come to your mind is that these salts, they are either acidic or basic. During hydrolysis, remember we just put the salt in water. We are saying it's either it will have a pH greater than 7, less than 7, or equals to 7. So you can see where we're going with this question. Now, the first question says define the term hydrolysis, which is what we talked about in our introduction, and we're able to say hydrolysis is a reaction of salt. Our salt is ammonium chloride with water. The reaction of salt with water, that is hydrolysis, meaning that we're going to put this NH4Cl, we're going to put it in water, and that is the reaction that we call hydrolysis. Now, if we move forward, you get 2 marks just to say it's a reaction of salt in water. You define hydrolysis and you have 2 marks. So we are always emphasizing know all the definitions so that you don't lose marks and you are able to collect as many marks as possible. Now, the question that comes after that is, will the final solution be acidic or basic? A good question. You are having a strong acid reacting with a weak base. It's like having a boxing match between a stronger person and a weaker person. Who will win? You ask yourself that question. The stronger one will always win. So if you're having a strong acid reacting with a weak base, obviously you are saying that now the strong acid will win, meaning that acidic. And the question is why? Why will it be acidic? It will be acidic because we are reacting a strong acid with a weak base. You see, always have that in mind, and it will help you to collect those marks. Look, the next question says, write down a balanced chemical equation that explains the answer to question 7.1.2. So you said it's acidic. So how do you do that? You're going to do hydrolysis. You're going to react this salt with water. And I would like to first, before I show you how to do the hydrolysis, or remind you to say it is important to always have a salt, which is NH4Cl, that is your salt. The first thing you can do for this salt is to split this salt into ions. You split it into ions, then you will form NH4 plus and chlorine minus. So you split the salt, you get NH4 plus and you get chlorine minus. Then the next step is to say, where is this salt coming from? Where is this salt coming from? So you're able to say that, okay, this salt is coming from ammonia, NH3. This salt, NH4 comes from NH3. Cl minus, you have seen that Cl minus is formed by hydrochloric acid, which means that this reaction was a reaction between HCl and NH3 as given there in the given information. So you're able to see that this is a salt of a weak base and a strong acid. And I've indicated that the strong acid and bases, they don't undergo their salt, they don't undergo hydrolysis. So no hydrolysis for HCl, no hydrolysis here, but the salt that will undergoes, or the part that will undergo hydrolysis, is the one from the weak base, our weak base. But now in your reaction, you are reacting the ions. Remember, you have split into ammonium ion, and chlorine minus. So you're saying this one won't change the pH of water, won't undergo hydrolysis. So it's only NH4 plus that will undergo hydrolysis. So the question was, write down a balanced chemical equation that explains the answer to question 7.1.2. So you want to show them that it is an acidic salt. How do you do that? You will take the NH4 plus. Allow me to use this base to write here. You will have NH4 plus water. This gives us H3O plus ammonia, NH3. You see? So now, this salt forms H3O plus. So that is a sign of acidic salt. So you are able to say, okay, what is the reason? What is the reason that this salt is acidic? It is acidic because when you hydrolyze this salt, it forms H3O plus, or because this salt is a salt of strong acid and weak base. So you can give either of those two reasons. All of them will be correct, and you'll be able to get your 3 marks there. So I'm thinking that you always look at that. We'll give you 1 mark for the reactants, we'll give you 1 mark for the products, and then for balancing the reaction, everything correct, you get another mark. Then you are 3 marks richer, and then you are able to enjoy yourself. I hope the issue of hydrolysis is clear to you. And if you get a question under hydrolysis with 2 or 3 marks, collect all those. Remember, 3 marks is 1% for the entire physical science papers, because we are writing out of 300 for paper 1 and paper 2. If you get 3 for hydrolysis, you know you have 1% already. So it's important that as you prepare for your exams, you know the process of hydrolysis. And you will see, as we check other question papers from other provinces, you will see that this question has been asked many times. And you can see that this is the question that you must always take care of. Now, we go to the next 7.2. You can see most of these question papers, when you move to the next questions like this one, 7.2, when you are doing neutralization and all your stoichiometric calculations, that's when the level of difficulty start to increase. That's when you start to do your calculations. And that's when majority of learners are losing marks. And our focus today, we want you to be able to collect these marks, more especially the ones that are based on calculations. Because with the theory, most of the time you are able to define, you are able to know what is hydrolysis, what is an acid, what is a base. But when it comes to stoichiometric calculations, we are saying spend more time doing these type of questions. Now, this one, it says, for the above titration, 25 cubic centimeter of 0.1 mole per cubic decimeter, that is the concentration. So you are given the volume of this base, you are given the concentration of this base. So you have the concentration and base. And you know those two because you know our run-to formula is C equals to N over V. That is our formula, our standard formula that we will always want to run to, or N equals to M over M, based on the given information. But already you can see for this base, we're having the concentration and the volume, which means we can calculate the number of moles. And that's how we want you to think, to say, what am I given? And what can I use this information for in order for me to answer the question? And they're saying it's titrated against 40 cubic centimeter. Then now we are given the volume of the acid. So you have the volume of the base, the volume of the acid, and the concentration of the base. You can see that formula that I talked about, the Cavanagh formula, the CAVA over CBVB equals to NA over NB. You can be able to refer to that formula, and you can be able to calculate other stuff if you were asked to do that. I'm just indicating how to collect information and how to look forward to say, what can I use this information for? So that is what we are given. And then here comes a question. Is HCl a strong or weak acid? So this is just a remembering question. We're saying HCl, we've talked about it a lot. We said HCl is a strong acid, and then it's not a weak acid, it's a strong acid. The next question, explain your answer. So this question is as good as say define a strong acid. So you can just write the definition of a strong acid to say it ionizes completely in aqueous solution to form a high concentration of H3O plus. So please always put it that way. Then you are able to get your 2 marks, and then you have 3 marks already that you have received from this type of questions. I hope this helps you. Now we continue with the question, but now immediately when I come to these questions, I would like you not to forget in your mind what we were given in the previous page. Remember, for us not to forget, we said we were given the volume of the base, which is ammonia. We're given there 25 cubic centimeters. We're given the volume. We're given the concentration. If my memory serves me well, it was 0.1 moles per cubic decimeter. All these were given for ammonia, which we said it was our weak base. And then we were given for HCl, we're given only the volume of an acid, which was 40 cubic centimeter. I'm writing this information so that we don't have to go back. And then the other thing which is important, maybe, if I'm to do that, is for you to remember the balanced equation. That our balanced equation, we're having HCl reacting with ammonia to form ammonium chloride as a salt, which is ammonium chloride, which is NH4 plus and chlorine minus. So it formed ammonium chloride. This is what we have so that we are able to answer the questions. Now, the question is saying, write down the name of the most suitable indicator for this reaction. So the question is, how do I know which indicator to choose when? That is the question that you are seated with. So what I would like to show you is that always check when you are given a strong acid like hydrochloric acid reacting with a weak base. We are saying the solution will become acidic, and we are saying that now this indicator that we will use there for acidic solution is methyl orange. Methyl orange. I just write M for methyl orange. Please don't forget. So methyl orange will be our indicator. And what will be the color change? Because that will be the next question that we can ask you. What will be the color change? You must be able to know that the color change there will be from red to orange. From red to orange. And then if you are having strong acid and strong base, I'm reminding you, you are going to have a neutral solution. And the indicator that you'll use is bromothymol blue. Bromothymol blue is the indicator, and the color change is from yellow to blue. Yellow to blue. And then if you are having a weak acid and a strong base, your solution will be basic. And what is the indicator? It will be phenolphthalein. Phenolphthalein, I'll just write P. So you can see from a acidic solution, neutral solution, and basic solution. I'm saying MBP for you to remember. MBP, methyl orange for acidic solution, and for neutral solution, we're saying bromothymol blue, and for basic solution, we're saying phenolphthalein. Please don't forget that. And the color changes as well, which in this case of a weak acid and a strong base, it will be from colorless to pink. Please know these color changes and you'll be able to collect these marks. Maybe in other questions you'll be asked, but in this one, we are only asked about the suitable indicator for this reaction, the reaction between strong acid, HCl, and weak base, ammonia. So the question is saying, explain, write down the name of the most suitable indicator, and I've indicated that it will be methyl orange. So you're able to know that this will be methyl orange. Give a reason. A reason is that we are reacting a strong acid. We are reacting a strong acid and a weak base. So you know that it's a reaction of a strong acid and a weak base. So the solution will be acidic. So we'll want to use methyl orange. I think I've emphasized that, and you will always remember that, and it will help you to get your marks. Now, we start with the calculations now. The question says, calculate the number of moles of ammonia in 25 cubic centimeter of the ammonia. So they want you to calculate the number of moles. So this one, you can see that I have the volume of the base, which is ammonia, it's 25. I have the concentration is 0.1. At least this one they gave you. At least you can be able to look at it and say, okay, this one I can know that, okay, the formula is C equals to N over V, and you know that C was given as 0.1. So you can just say 0.1 equals to N, we want number of moles, V was 25. But remember, it's 25 cubic centimeter. That's where our learners use these marks. You always convert to the correct SI unit. In this case, it must be in cubic centimeter. So you must be able to divide by 1,000 or to multiply by 10 to the power of minus 3. So this becomes zero. Number of moles here will become 0.1 times 25 times 10 to the power of minus 3, which if our math is correct, the number of moles will be 2.5 times 10 to the power of minus 3 moles. So you are able to do the calculation. I know you have calculators and you have done that, and I hope it has given you the same answer as mine. Then you know you're able to get your 3 marks there by doing that basic calculation that we have. It's just a routine equation where you write the formula, you substitute, you cross multiply. We most of the time you have seen in both paper 1, paper 2, we're always advising you not to make subject of the formulas and all that before you substitute. Copy the formula the way it appears in the data sheet, substitute the values in the formula, and be able to find your correct answer with correct SI unit. So it must be in moles. Remember, if we don't write moles there, we'll take our 1 mark away. So you are able to get 1 mark for the formula, 1 mark for the substitution, and 1 mark for writing the number of moles. And then I hope you got that 3 and you are happy. Now, here's the question. The question is coming now. Real things for 8 marks. The question is saying calculate the pH of the final solution. You see now the story now, the keyword there, of the final, so not the initial solution, the final solution. If the concentration of the original HCl was 0.1. So they gave you original, but they are saying now calculate of the concentration of the pH of the final. So they are saying you can't use 0.1 because 0.1 is what we had initially. They are saying final at the end, we want you to calculate pH at the end after the reaction has taken place. So this is very much important that you have that understanding, and I hope this is going to help you, and then you'll be able to answer this question. And then we have done this 7.25. We agreed on everything there, that this is how you'll go about doing it. But now let's look at how you'll go about this question. Remember, the first thing that you are always looking at is our given balanced equation. Our balanced equation, we were given HCl reacting with NH3 to form NH4Cl. This is what we were given in our reaction. Now, but initially, we calculated the number of moles of ammonium. This one, we calculated the number of moles of ammonium in our previous question. We got that it was 2.5 times 10 to the power of minus 3. That's what we calculated the number of moles of ammonium. Now, of this number of moles of ammonium, what is the mole ratio? Remember, the mole ratio is going to give us the number of moles of HCl. That is the first step that you'll go. You'll say, okay, I'm going to use, because I know the number of moles. Remember, the 0.1 they gave us is the final one. The final one. So we want to work the number of moles initially. What did we have? So you will say, okay, we used 2.5 times 10 to the power of minus 3 of ammonia. So according to the mole ratio, is 1:1, which means the number of moles of HCl is 2.5 times 10 to the power of minus 3. Please have that in your mind, and it will help you. The problem will just become simple. Then continue to work around this 2.5 with the mind that finally, originally you had 0.1. So what reacted there? We had 2.5 times 10 to the power of minus 3. So we can calculate the concentration of HCl now. We calculate the concentration of HCl, which is N over V. The N, we said, is the same as the ammonia one. So you will write that. Our volume, we were given volume. Remember, in our given information, we're given the volume of a base. We're given it as 25 cubic centimeter. We're given the volume of the concentration of a base. We're given as well as 0.1 mole per cubic decimeter. We're given the volume of an acid, which is our ACl, which was 40 cubic centimeters. So you got to multiply by 10 to the power of minus 3 or divide by 1,000. So hence, when you divide 40 by 1,000, you will get the volume there. So you have the number of moles that reacted with this one is 2.5 times 10 to the power of minus 3. You are having the volume, which is 0.04. So we give you a mark for that. So you have 1 mark for using the mole ratio. So mole ratio, as long as you are doing stoichiometry, mole ratio is important, and always refer to the mole ratio, because there will be 1 mark for mole ratio, and we don't want you to lose that 1 mark for mole ratio. Now, after you've done that, you are able to now calculate the concentration of ACl that reacted. How much? Remember, we are saying 2.5 times 10 to the power of minus 3 of ammonia reacted. And according to the mole ratio, 1:1. It means the same amount, 2.5 times 10 to the power of minus 3, will react of HCl. And then because of 1:1, you use that to calculate the concentration. We got it. Now we can be able to say, okay, let's go back. How much were we having? We were having 0.1. How much reacted with ammonia is 0.0625 according to this calculation. 0.0625. How much is in excess? So the difference of that, we had 0.1, we reacted to 0.0625, we are left with 0.0375, because when you calculate the pH, this is the concentration that we are supposed to use, the concentration at the end, after the 2.5 times 10 to the power minus 3 have reacted with ammonia. Then we are left with the concentration of 0.0625. I mean, we use the concentration of 0.0625. How much concentration is left? We are left with 0.1 minus 0.0625. And we are left with 0.0375. Remember, this is the concentration of what? Is the concentration of HCl, not hydronium ions. So you must go and do the mole ratio. 1 HCl forms 1 hydronium ion, 1:1. So for doing that, again, you will get another mark for using the mole ratio between H3O plus and HCl. Then you are able to get that 1 mark. And then because the mole ratio is 1:1, it means you can now calculate the pH. Remember to calculate the pH, you will write the pH formula, which is minus log the concentration of H3O plus. You copy the way it appears in the data sheet, guys. And we are always emphasizing that. See how the P is a small p, capital H. They are not the same, they are not equal. If you are going to write pH like that, hard luck. We won't be able to help you in terms of you utilizing it, that equation. So it's very much important that you are able to move with it. And you see the formula is from the data sheet. You just trace it. You write your answer, which is now 0.0375 minus log 0.0375. You punch it in your calculator. You take your calculator. You punch minus log, and then you say minus log. And then I hope you are doing it, because you must practice, guys. You must not do this the first time in the exam. It must be something that you are used to do as you are practicing now. And you are able to get 1.4259. Then you can round it up to 1.43. And you know our pH doesn't have units, so you don't have to write the SI unit. So that is how you do your stoichiometric equations. And we are saying that continue to utilize it, continue to do it like that, and you would enjoy yourself. I hope you have enjoyed our first stoichiometric calculation in terms of calculating pH from this. Remember, always look at the keywords in the question, because they said calculate the pH of the final. If I can go back to the question, it said calculate the pH of the final solution. So not the beginning, not what reacted, no, of the final, at the end, how much HCl is left. We're saying no, the HCl that is left is the one that we'll utilize to calculate the pH at the end. You can't use the original. So if you just came, you say pH plus minus log, then you say 0.1, you can see yourself that you can't get 8 marks for just doing that. You must first check how much HCl reacted. How much did we have initial? Then you subtract from the original, you subtract the reacted ones. You left with the excess one. Then you use the excess to calculate your pH. which is what we did here. I hope you have understood that question, and it will help you as you prepare for your exams, and you will start to enjoy these type of questions. Now we are going to do the question paper at KZN, still now during the prelim exams. Let's look at this question paper now. It starts like this. They say the hydrogen carbonate ion, which is HCO3 minus, is an ampholyte. So they are telling you that HCO3 minus is an ampholyte. So the first step, they are saying define an ampholyte. Sometimes they'll say it's ambiprotic. So you must know all those names that refers to an ampholyte. So an ampholyte, we are saying, what is an ampholyte? We are saying this substance, then ampholyte, it can act as an acid or a base. It can act as an acid or a base. It means it can donate a proton, it can lose, it can gain a proton. It can do both. It can act as an acid. It's a proton. It can be a proton donor. Can be a proton acceptor. So I'm hoping that you get that correct. That it is an ampholyte because it can act as an acid and can or a base. Write a balanced equation to show the reaction when hydrogen carbonate ion reacts with water. So now you're just putting it in water. That is HCO3 minus. I'll just write it here at the top for the sake of the space. HCO3 minus in water, H2O plus. Then you are able to show that, okay, what will it do now? Will it be acidic? Will it be basic? Remember, when it's HCO3 minus, you can see that it's running short of that H plus, so that it can be complete. So what will happen? Will it be acidic or basic? Then you are able to write this. Okay, it will be able to form now our H. If you take the H there, it will be H2CO3, which is our carbonic acid, plus the OH minus. So you know that this must be a basic. It must be basic because it forms the OH minus, and then you are able to look at it that way. Or you can use your two water, and then still you can be able to do the reaction, and then you are able to get your 3 marks. Now in question 7.2, have you seen that this 7.2, that's when things starts to become more interesting. We're starting to do our stoichiometry, and we're saying don't be afraid of stoichiometry, practice it, have a knowledge of it, you will enjoy it, and that's the direction we want you to go. Now they said a flask contains 20 cubic centimeter of what? Of dilute sulfuric acid. Lot of information there. You are able to say, okay, is 20, this is the volume of an acid. Or is dilute. Dilute means dissolved, or the proportion is dilute. It means we have the less number of moles in proportion to the volume of water. Always remind yourself those definitions so that you move with them and they help you to have the understanding. 0.15. Oh, hence they said dilute. 0.15. You can see we have more less N and more of volume of water there that is added. Hence it's 0.15. Definitely say dilute sulfuric acid. And what else do you know about sulfuric acid? The other information that sulfuric acid is a strong acid. You know that sulfuric acid is a strong acid. It's always important for you to remind yourself that this is a strong acid. It's just that it's dilute. To say it's dilute, it means there is less number of moles in proportion to the volume of water. Sorry for that. And then you are able to do that, and you have that information. So you have the concentration of the acid, you have the volume. If we say calculate the number of moles, it's just straightforward. It's just plug and play. You know C equals to N over V. So you always have that in your mind to say, if the question comes like this is how I will tackle the question. Now, let's look at this one. It says calculate the pH of the dilute sulfuric acid. What a question, a nice question for you. Just for a minute, I'll just keep quiet for a minute. I'm not going anywhere. I just want you to take your calculator, do the calculation. Let's see what you get there. Thank you. Welcome back. I hope you have done your calculation. Remember, we've emphasized the P is small, the H is big. How you copy the formula from the data sheet is important. You copy it as it appears, then you'll get a mark for doing that. Provided you rest that formula, you substitute into that formula. So you wrote pH equals to minus log the concentration of H3O plus. Now, the first thing that you see, there is no H2SO4 in this formula. There is H3O plus. That is the first thing we must acknowledge. So it means now our job is to find the concentration of H3O plus. Because we're only given the concentration of H2SO4, not of H3O plus. So you will know that if you are having that, you will say equals to minus log. Then if you write 0.15, you will have got it wrong. Why? Because we're talking about a diprotic acid. A diprotic acid has those two hydrogen ions that it must donate. Hence, for diprotic acid, you must multiply the concentration of the acid by 2 to get the concentration of the hydronium ion. So it forms 2 H3O plus. Hence, it is 1:2. So know that for diprotic acid, I'll multiply the concentration of the acid by 2 because 2 H3O plus will be formed. So that is the only thing that you are supposed to do. Then you take your nice calculator, you do the same. You set minus log, and then you are able to say 0.15, and then you multiply that by 2. You multiply 0.15 by 2 is 0.30, so you can just say minus log 0.30, and then you got 0.52. Then you write your answer, that is 0.52. And you know we don't have SI units of the pH, you just write it like that. And that's how you got your 3 marks, guys. I hope you got it and you're enjoying and you're able to see that. Why do we use this trait? Because we're given the concentration and they say calculate the pH of the dilute sulfuric acid of this acid. But if they say of the final, it means there is something that must happen first before you use the pH formula. But in this case, immediately they gave you the concentration, you can go straight to the calculation. So let's differentiate. When do we have to do the calculations first before we use we calculate the pH? In this case, it's straightforward. You can just write the formula, plug in the substitute, and then after substituting, you are able to write the final answer, and you got it like that. And that is your memorandum. As we said, that's what you will do, and then you are able to do that, and then you are able to get your answer, and then we're able to move forward. We're able to move forward, and then your pH there is 0.52, and then that's what we got there. Now, with no waste of time, we go to Northern Cape. We're given hydrofluoric acid, which is HF. We are told that it's a weak acid already. You think about the definition to say it will ionize. It will ionize in completely in aqueous solution to form low concentration of hydronium ion. So you will always start with those definitions, guys, and you are able to do that. Look at that. The first question, define the term weak acid. Then you are able to define what a weak acid that will ionize in completely in aqueous solution to form low concentration of hydronium ion. With 2 marks, you do that, you write it correct. Now, they say a sample of hydrofluoric acid has a pH of 4.5. Has a pH of 4.5, and then at 25 degrees Celsius. If it's a pH of 4.5 at 25 degrees Celsius, and then that is what we are having now there. So you're able to see that a symbol of that has that pH. Now the pH is given, have that in mind. The question now is saying calculate the concentration, because pH is given. Now they're saying calculate the pH, the concentration of hydronium ion. So you can see that now the formula is still the same, pH equals to minus log concentration of H3O plus. You do that, you write your formula as you expected, and then you are able to say, okay, pH is given is 4.5. 4.5 equals to minus log H3O plus. This is important, guys, that you first do that, you follow the formula, and then you can do what you say anti-log, or you can remove the log, and you'll be able to get that the concentration of H3O plus will be equal to 10 to the power of minus 4,5. And then you just have to put that into your formula. 10 to, that's how you remove the log. You say, if I'm to write the formula, I can just say a concentration of H3O plus is equal to 10 to the power of minus pH. So it's equal to 10 to the power of minus pH. You got to have that, and then you are able to do that. You just go there and say, okay, concentration of H3O plus is equal to 10 to the power of minus, then you go to 4,5, and you go to your nice calculator. You said, what is 10 to the power of minus 4,5? Then after using your calculator, you say equals to, and then you're able to get your number, which in my calculator is saying 0,000316, which you can say 3,16 times 10 to the power of minus 5, if not mistaken. And then you are able to write that as your concentration of H3O plus. So I hope you have seen that, and you are seeing now that we were asked to calculate the first question that we did. We were asked to calculate the pH of the final solution. Then we had to check what reacted, what we subtracted from the original, and we calculated the pH. The second one, we were asked to calculate the pH of a diprotic acid. We said, because this is a diprotic acid, we'll take the concentration of the acid, we'll multiply it by 2, because a diprotic acid forms 2 H3O plus. So then we're able to do that, and we're able to do our calculation. On this one, we're given the pH now. We're saying calculate the concentration of the H3O plus, and we're able to say, you'll write the pH formula as it appears. Always do that. Then you will substitute that formula, and then you will say H3 concentration of H3O plus is equals to 10 to the power of minus pH. You just write minus 4,5. You just use your calculator and get the concentration. I hope you got that, and it will help us as we move forward, because you will always remember that's how we do it, guys. And these are the marks that you must collect at all times. These are your marks for the taking. So that is the paper from Northern Cape. The next question said, we are told that when hydrofluoric acid, HF, which we are told that is a weak acid, when it reacts with sodium hydroxide, we know sodium hydroxide is a strong base. So we have a weak acid reacting with a strong base. So you are able to look at it and say, okay, a weak acid plus a strong base, the solution would be basic. The solution would be basic. Remember, we talked about the types of indicators that we can use. We said for this one, because it's basic, we're going to use phenolphthalein, and we talked about the color changes from colorless to pink and all that. So have that at all times so that you are able to remember. And when you see a question, you check, is it a strong acid and a strong base? What is going to happen? Let's look at this one. They're saying, will the pH of the sodium fluoride, the product, the salt that is formed, sodium fluoride, which is a salt of a strong base and a weak acid, will that be greater than 7, smaller than 7, or equals to 7? You see now, it's important because this is the same question but asked differently. What is different? What is different here is we are saying, will it be greater than? When you say greater than, we are saying basic. Remember, greater than 7 is basic. Will it be smaller than? Smaller than, we are saying acidic. Will it be equal to? Equal to 7, we are saying neutral. So it's important that you see that it's the same question, but now instead of saying acidic, neutral, or basic, we are saying greater than, smaller than, or equal to 7. So in this case, we said it's a strong base and a weak acid, so it will be basic, and because it's basic, it will be greater than 7. And you collect your mark, and they say give the reason for your answer, and you are able to say the reason is that it's a reaction of a weak acid and a strong base. So it's a salt of a weak acid and a strong base. So you're able to see that, and we are able to move forward. You gave the reason, you got. That's how you get your marks. So we calculated our pH. We had 2 options there. You just write our formula, then 4,5, then you use the antilog there. You get that 3,16 times 10 to the power of minus 5, or you can just say 10 to the power of minus 4,5. It's at the top here, minus 4,5, and then it gives you 3,16 times 10 to the power of minus 5 moles per cubic decimeter. Then you go to 3 marks, and we're saying now the pH will be greater than, because it's a salt of it's a strong base reacting with a weak acid. Just look at the marks that you are able to collect. Now, we go to your favorite question, the questions that we are saying, these are the questions that we must collect. These are the questions that we must make sure that we are doing well when it comes to them, and we collect all the marks and we move. Because once we do well on these types of questions, I'm telling you, a season basis, you will go and enjoy yourselves there. Now we're saying 7.2 in a reaction. In reaction a 3.5 grams of pure magnesium carbonate reacted completely in 50 cubic centimeter of HCl. Given information, very much important. So we're having our base here, which is a weak base. You know, this is a weak base. Magnesium, all the carbonates, we said they are weak bases. Remember, the strong bases, we said are the hydroxides. The hydroxides are the strong bases. So magnesium carbonate, the carbonates, all of them weak bases. So we have a weak base and a strong acid. So it's important you always ask yourself, is this strong, is this weak? So that when you start answering the questions, you are talking to the real thing. So we are having now 3.5. So when you're given mass, I know when you're given mass, what comes to your mind? The mass is 3.5. Always when you're given mass, you think about number of moles, which is mass over molar mass. And then for the HCl, we're only given the 50 cubic centimeter of HCl here. The balance equation for the reaction is given below. So we have the balance equation. Let me go to it for reaction 1. So you're able to see that, okay, we're having magnesium carbonate plus 2HCl, 2 hydrochloric acid forming the salt, magnesium chloride, carbon dioxide, and water. So there are there is carbon dioxide as well that is formed there. Now they are saying this is what happens in this reaction. It's very important, learners, to have this understanding that we are having a reaction here. This is what happened. We have 3.5 grams of magnesium carbonate. We have the volume of HCl, which was 50. But they are saying HCl is in excess. So there will be HCl that will remain. Remember, in our first page calculation, we did the same. Even here, they're saying we have HCl in excess. And that HCl will neutralize 20 cubic centimeter of sodium hydroxide solution. And that has a concentration of 1.2 moles per cubic decimeter. Now, it's important, this first information is important for us to understand what happened here in this reaction, because whatever that will happen, HCl will remain, and the remaining HCl we are going to react it with sodium hydroxide now, which is a strong acid reacting with a strong base. So I want you to have that understanding. And the good thing is that for this base of ours, we are given concentration of a base, which is 1.2 moles per cubic decimeter. We are given volume of a base, which is in this case 20 cubic centimeter. So you are able to see that we are given nice things that are given there, and you will be able to move with no problem. Now, in reaction B, in the second reaction, where we are reacting HCl and sodium hydroxide, that is the second reaction. Now, the first question, calculate the number of moles reacted in reaction A of HCl. And you see that for HCl, we're only given volume there. So obviously, you will go back to the balanced equation. What are we given? We are given 3.5 of magnesium carbonate. Then you will do that. Then you will use the mole ratio. I want you to have understanding. You will calculate the number of moles of magnesium carbonate because you are given the mass, and you can get the molar mass in that case. So once you have done that, you have calculated the number of moles of magnesium carbonate, you will be able now to use the mole ratio to say 1:2, which means you multiply that number of moles by 2 to get the number of moles of HCl. Because you want to know how much of HCl reacted. That is what the question is saying. How much HCl reacted with the magnesium carbonate. So how will I know? Remember, this one is in excess. This one is a limiting reagent. So it means the magnesium, this 3.5 reacted, it was all of it reacted with what? With HCl. But with HCl, some of it remain. Hence, we're going to have it in excess. I think we are together there. Now, what happens? You calculate the number of moles according to 7.2.1. Then obviously you will say, okay, number of moles is mass over molar mass. and then you know that the mass we're given is 3,5 of magnesium carbonate, MgCO3. Don't forget what we talk about MgCO3. You are dividing that 3,5. You are dividing that 3,5 by the molar mass. Remember, molar mass, you are checking, that is your magnesium. I think you'll say your 24 plus 12. I think it gives you 36 plus 48. And then if my maths is saving me well, you'll get 84. 3,5. I'm just doing it off my head. Maybe I can use my calculator. It's 24 plus 12 plus 3 oxygens. Each has 16, so 16 times 3. That gives you 48. So you say 24 plus 12 plus 48. And then you are able to get 84. I was correct. Then you do your 84 there. Then to get the number of moles, you are going to say 3,5. I know you have calculators. You are doing it wherever you are. 3,5 divided by 84. And then you are able to get your answer there, which is 0,0416. So it's something like 0,042. I can write like that, 0,042 moles. That is the number of moles of magnesium carbonate. Now you must use the mole ratio. You see the importance of mole ratio to say, okay, this one, it represents magnesium carbonate, but I'm looking for HCl, so it will be 2. So it's 2 times 0,042. So that will give you 0,084. That will be the number of moles that has reacted. You will see when I show you the solution. The next question now says, calculate the concentration of the original solution. You see, now they want us to say, what do we have when we started? So we have to calculate the concentration of the original solution of HCl. We know how much reacted. What reacted is 0,042. But what do we have initial? So the answer is always there in our eyes, but it needs us to have to open them so that we can see very well. Because if we check on the statement, we are told that excess HCl neutralizes exactly 20 cubic centimeter of sodium hydroxide solution with a concentration of 1,2. So these two, C and V, can give us the number of moles of sodium hydroxide. And if we check here, the mole ratio here, it is the same mole ratio. So you know that if I find number of moles using this and that 20, remember that 20 must be 20 times 10 to the power of minus 3. You must divide it by 1,000 because you want it in cubic decimeter. So if you do that, you are going to say, okay, N equals to C equals to N over V. Then you are able to say, okay, C equals to N over V. And then you know your C is 1,2. You know V is 20 times 10 to the power of minus 3. So you are able now to find the number of moles of sodium hydroxide, which according to mole ratio must be the same as the number of moles of that one. And if you know the number of moles, you can be able to calculate the concentration that was used to react exactly with that. So at the end of the day, you will know how much you will be able to add what reacted in B and what reacted in A, and they must be able to give us what we had initially. So the question you can see is the same question. We're just going around, and if now you start to learn how to go about these type of questions, you won't have a problem. So here, I was just showing you how we worked up the 0,084. Let's look at the memo for 7.2.2, which is our interest. So the first thing that we've done, we said, okay, C equals N over V. We said, okay, 1,2 times 0,02. Remember, we were given 20 cubic centimeters of sodium hydroxide. So you are able to multiply that. You get the number of moles of sodium hydroxide. You use the mole ratio, 1 mark. Please don't lose that mark of mole ratio. If you are doing this type of question, have the mole ratio in your mind to say, I have 1 mark for doing the mole ratio. Because we'll always look at the correct mole ratio, because that mark is for correct mole ratio. Now, and then as I indicated, you will take what reacted plus what we had in excess. Remember what reacted in the first reaction? We had the first reaction where we were reacting with magnesium carbonate, and we said what reacted there was 0,084. That's what the number of moles that reacted. What we have in excess, which is the same as this one that we used in the sodium hydroxide, which is 0,024. then you get 0,024 there. Then when you add the 2, you have the original that we are having. So I think you are enjoying these questions, and you will start to practice as many questions as possible, because immediately when you have the number of moles, you can now easily say the concentration of HCl that we had initially is this one that is we had initially is the number of moles, initial number of moles divided by the 50. Remember, we're given 50 cubic decimeter. So you multiply by 10 to the power of minus 3, you get 0,05 by dividing by 1,000, and then you get your answer, which is 2,16 moles per cubic decimeter. And then there is a range. Remember, if you are doing the rounding offs and all that, your answer must be between that range of 2,08 and 2,16, and then you are able to get all your marks. And I'm hoping that this is giving you even much confidence to deal with this type of question wherever you come across them. Just say, no, this is not difficult. It just need you to have an understanding, or what do I have, what do I need, so that you can see. So you can see now this is the third way of doing things, because in this one we were able to check what reacted with magnesium carbonate. We were able to check what was left, what was in excess, that reacted with sodium hydroxide. And we're able to say, okay, this much reacted with sodium hydroxide. Then if we add these two that reacted, because the whole HCl that we had reacted, so if we add the two, we're able to get the number of moles that we had original or at the beginning. And then if we have that, we divide that by volume, we're able to get the concentration that we had initially, or the original concentration. So I hope you're enjoying this session, and you are doing questions, and you look at acids and bases with a different eye and be able to say, I can solve these problems. Now look at this. They are saying ammonia. I think we came across something like this, so it won't take time. Ammonia reacts with HCl to form a salt as shown. This is from Metronorth, that is Western Cape. Identify the base. The base, remember, HCl we know is a common acid, strong acid, and ammonia we said is a weak base, it's a common weak base, ammonia. So you're able to say the base is ammonia in the above equation. You can say NH3, or you can say ammonia. Give a reason for your answer. Remember what a base does. It's a proton acceptor. It's a proton acceptor. It will accept a proton from an acid, because an acid is a proton donor. This one is a proton acceptor, meaning that it will accept a proton from HCl to form NH4 there. Hence, we're having NH4 Cl minus. In other equation, will give you the same as NH4 plus chlorine minus. Remember, this is ionic bonding between those two, hence they are written as ammonium chloride, which is our solid there, our salt. Write down the name of the salt formed, NH4Cl. So the expectation was learners to write ammonium chloride. Ammonium chloride. Please know the names of these acids, common acids and common base, even their products, what the kind of salt that they can form. As you can see in that question, learners were asked to write down the name of the salt that is formed. Now, ammonium chloride can undergo hydrolysis. Remember, you now know that question, and then you can answer that question with no problem. Define the term hydrolysis. Remember, we said it's a reaction of salt and with water, not and. It's salt with water, a reaction of salt with water. That's how it's defined in our exam guideline. Write down a balanced equation for the hydrolysis of that. We have shown it. We said this is NH4 plus. After you separated the salt, because the chlorine minus comes from hydrochloric acid, does not undergo hydrolysis. Only the NH4 plus will be added to the water, and then you are able to form ammonia, and H3O plus. So you're able to know that this is an acidic salt because it forms H3O plus, or because it's a salt of it forms when you put it there, or it's a salt of a strong acid and a weak base. It will be acidic salt. So always you have that in mind. Any question that can come, you are able to respond. And the indicator will indicate whether the solution will be acidic, alkaline, or neutral. I've already said that it will be acidic because it forms H3O plus, or because it's a salt of strong, is formed from weak base and strong acid. So these questions, you can see when you look, they are common questions that always they are being asked in all these provinces. Hence, we are saying practice, 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 and ensure that you have all these question papers from all the provinces. And when you practice all of them, and then we know that you are ready for example for the exam. Oh, when you see that, you see that these are the apparatus for neutralization. So I like this because in your exam guideline, we said you must be able to identify, you must be able to label the apparatus. That's one thing you must be able to know. The next thing, you must be able to write to write down the steps for titration, to say when you are doing titration, so what are the steps that you are expected to follow. Remember, in this case, we're having our rotate stand here, and then we're having our flask here, which you can call it conical flask. You can call it, some will call it Ellen Meyer flask, and then you are able to call it like that, and we have no problem. Now, you are having your conical flask, you are having your burette there, and then you are able to use that to put your indicator there. Remember, in this case, we're having a base in the burette, we're having an acid in the conical flask. Remember, on the conical flask, that's where we'll always put our indicator. And the choice of indicator, we said, depends whether you are having a strong acid and a strong base, or a strong and weak. So in this case, we have a strong acid, sulfuric acid, and a strong base. Definitely, this will be neutral. And we said, don't forget MBP. I said promothymol blue is in the middle there for neutral. So promothymol blue will be the choice of the indicator. Remember the color changes as well, because we say Roy B cap. I told you that when we start, that for color changes, we are saying Roy B cap, so that you always remember this and collect these marks, guys, and enjoy the papers. Remember, I said MBP. M for methyl orange is used for acidic solution. Acidic solution that is a strong acid and a weak base. We'll use methyl orange, color change red to orange, and then for this one, for neutral, we said we're going to utilize, for neutral, we're going to utilize promothymol blue. Hence I said, okay, that is neutral, that is promothymol blue. Hence I said MBP. Promothymol blue is for neutral, which is strong acid plus strong base. We use promothymol blue, and the color change will be from yellow to blue. And then methyl orange, the color change will be from red to orange. And we are saying it's when we use a strong acid and a weak base. So we're able to do that. And then lastly, we're able to say, okay, for the last one is when we have a weak acid and a strong base. We're going to use phenolphthalein, and the color changes from colorless to pink. This is very much important, because when you deal with this type of questions, this is definitely what we are dealing with. Remember, I talked about the titration equation, the Cavanagh equation that I talked about, which is Ca Va equals to Na, which is Cb Vb, and Na over Nb. So you are able to know that equation, and this is what we use here. So already you can see we are set. We can start now with our titration and our questions, and it will be straightforward. The diagram below shows the titration of 25 mL of sulfuric acid. So you know that here we have 25 mL of sulfuric acid, and then with the concentration of 0.2 moles of sodium hydroxide. So the one that has a known concentration, we call it standard solution. So standard solution, our standard solution is sodium hydroxide, because we're saying standard solution is a solution of known concentration. So you are able to know that this one is a standard solution because it's a solution of known concentration, and our concentration is 0.2 moles per cubic deciliter. So you can see, if we were to use the Cavanagh formula, you can see already we have some volumes, we have some concentrations. You are able to do the substitutions. Now, the balance equation is given below, and then we're given that sulfuric acid plus 2 sodium hydroxide forming sodium sulfate plus 2 water molecules. Identify apparatus A. So you know A, we said it's a burette. So you must know that this one is a burette. It's a burette, double T. It's a burette. And then we are saying again, promothymol blue was used. Oh, promothymol blue, we talked about it. So promothymol blue, yes, for strong acid and strong base, neutral solution, we will definitely need. Write down the color change. You see now the question is about color change. You are able to say the color change from yellow to blue. So you are able to use that, and it helps you to score as many marks as you can in this particular topic. Choose between blue to yellow, yellow to blue. Already I've chosen for you that is yellow to blue because I've shown you there. So I'm hoping that you will have all this information and it will help you. We're doing the West Coast as you go to the complete of our session. I define the term pH value. This one, you were saying, is a negative logarithm of the concentration of H3O plus. You're just looking at the formula itself. It's a negative logarithm of the concentration of H3O plus. That's how they defined it in the West Coast. And then in the following table, two ampholites are indicated. Two ampholites are indicated. So they are saying water and HSO4 minus, both these two. They are saying these two are ampholites. Copy the table on your answer set and complete the conjugate acids and bases of each ampholite. On the left, we are writing the conjugate acid. On the right, we are writing the conjugate base. I found this a very nice question because it's for you to be able to see the difference between a conjugate acid and a conjugate base. Because we are saying a conjugate acid will have more hydrogen ion, so it will be H3O plus because you know that a conjugate acid has H plus, more H pluses. So even here, the conjugate acid will be sulfuric acid. But the conjugate base will remove the hydrogen ion. The proton must be removed. Then you definitely, when you remove hydrogen ion there, you'll get OH minus. When you remove another one there, you'll get SO4 2 minus. So please be able to know the issue of conjugate acids and conjugate base because this is just something that you can get and it's nice if you know. Give formula of the salt formed during the following acid base reactions. So if you're having a reaction between ethanoic acid and sodium hydroxide, definitely you will form a salt called sodium ethanoate, which is CH3COOO-Na. Remember how the salt is formed is the reaction between a salt, strong base, and weak acid. Then you form sodium ethanoate. And then the salt that will be formed there, it will be your magnesium nitrate. So you'll have your Mg and then NO3. Don't forget magnesium is in group 2 in your periodic table there. So it will need NO3 is a -1. So it will need 2 NO3s there. So it must be MgNO3 with a 2 there. Then you know that you are set and you are able to move. That is magnesium nitrate. And with that part, we are done with that question. And then we are able to move as that happens. And then if we move to the next, if you see, that is the solution, which is definitely what we dealt with. We're able to define the pH value. We said it's the negative logarithm of the hydrogen ion concentration, or we can just say hydrogen ion concentration in a solution. Then you're able to get your 2 marks there. And then there was a question of writing the salt. It's CH3, CONA, MgNO3, 2 there. You are able to write those salts like that. I'm thinking that we are moving together as we go to our next question that we're going to do, which is now the DBE. So we are closing now with the May-June paper that you wrote, that was written by those who were writing supplementary exams. We've done, I think, 5 provinces that we went through. So you were able to see how those questions are asked. Now we're going national now to look at the national paper that was written for the supplementary, and I'm hoping this is helping you and you will always now know and be confident. This topic was saying go and collect all those marks. Now, a standard solution. Immediately when they say standard solution, remember the definition. What is a standard solution? We're saying this is a solution of known concentration. We're saying it's prepared by dissolving 10 grams of sodium carbonate. 10 grams of sodium. Immediately when you see grams in your mind, you know grams. Then what comes to your mind? It is that we can calculate the number of moles. And we are given the volume there. So we can even calculate concentration. So those things are important for you to do data collection to say, okay, I have mass. I can say number of moles equals to mass over molar mass. I'm given volume. I can say C equals to N over V. Already you have a light. And we are saying the salt we're talking about is sodium carbonate. And it's important for you to always ask yourself, this salt is a salt formed by what? By sodium hydroxide, a strong base, and obviously a weak acid like carbonic acid. So you know that this must be a basic salt because it has a strong base, sodium hydroxide, and it has a carbonic acid, which is in this case a weak one. So you are able to look where the salt is coming from. You are able to look whether it will be acidic. Sometimes you'll say, will it be acidic, or will its pH be greater or equals to greater than 7, less than 7, or equals to 7. So those are things that, so this one definitely will be greater than 7 because it's a salt of a strong base and a weak acid. Calculate the concentration of the solution. So you can see already given information tells you the question what is coming. You're able to say, okay, I have mass here. I can calculate number of moles, which is mass over molar mass. And then I have volume here. I can say the number of moles I will get, C equals to N over V. And then others will say, no, I can combine these two equations and get one equation and say C equals to mass over molar mass times volume. Still, you will be able to calculate your concentration. So I'm hoping all this information helps you when you move towards answering this question, because the molar mass was given as 10. I mean, the mass of sodium carbonate was given as 10, and then you know the molar mass of sodium. My mind served me well, is 23, and then 23 times 2, that will get about 46 plus carbon, which is 12, and then you have 46 plus 12, which will be about 58 plus 48. That is coming from 48 plus 58. If I'm doing my math correct, I hope you have calculators. You are calculating the molar mass of sodium carbonate, and then that is giving me something like 104. I'm just hoping and praying that I've done it correct. Then you have 104 grams per mole. We have our volume, which is 0.7. So you can see that you just plug and play. Hence, it's 3 marks. It's a routine question where you just have to substitute what you are given and you are able to get your answer. I've attached the memo. There's no problem. You'll be able to check. Will the pH of the solution be greater than or less than 7? You can see this question is being asked many times, and we indicated that sodium hydroxide is from, sodium is from sodium hydroxide, which makes this a salt of a strong base and a weak acid, which is a carbonate. And then we are able to know that this will be greater than 7. Now write the equation that explain the answer to question 7.1.2. So remember, when you are having a salt, you can put that salt in water. And what you are having here is a CO3. In real sense, remember the steps that we talked about. We said when you are given a salt, you can separate your salt, which in this case it will be 2 sodium plus and the CO3 2 minus when you separate that salt. So you can add water to CO3 2 minus plus water. It will give you HCO3 minus plus what is left there, OH minus. So you're able to look at that and be able to say this is what will happen. And you're able to see that because it forms a OH minus, it is a basic salt. Sometimes you can use 2 waters, still it will give you CO3, then you'll have H2CO3 here and 2OH minus, which still shows that it forms OH minus. So it's a basic salt. It's a salt of a strong base and a weak acid. So you are able to do that. You get your mark there, and then that's what we did. We calculated the number of moles. We used this formula, and then 10. It was 106. I said 104. It was 106 times 0.7, and then it gives you 0.13 moles per cubic decimeter. So you are able to do the calculation, you get it, and you are celebrating. And you can use the number of moles and the C equals to N over V formula. Still, you are able to do it, and you do it correct. Now, let's look at this. Still the same question paper. Sodium carbonate solution is titrated with dilute hydrochloric acid. Remember, don't look at dilute, because dilute is just telling us that this is a diluted strong acid, but it's still a strong acid. So we're having a reaction between a strong acid and this base that we're having, which is sodium carbonate. When you titrate that, which is sodium carbonate, which is which is a base, which is a weak base. Sorry for that. It's a weak base and a strong acid. So sodium carbonate, which is our weak base, and hydrochloric acid, which is our strong acid. So it's a weak base. So sodium carbonate, all carbonates are weak bases, and then hydrochloric acid, and then we are saying this one is a strong acid. So a strong acid and a weak base, you know that this must be acidic. This must be acidic, and remember what we said. So acidic, we said we'll use methyl orange. If it's neutral, we said we'll use bromothermal blue. If it's basic, we said we'll use phenolphthalein. We said the color changes from red to orange, from yellow to blue, from colorless to pink. So we are here. We are here at acidic. So we'll use methyl orange, which is the first range there. Methyl orange, which is now the type of an indicator that we'll use. Which one of the indicators, PQR, is the most suitable for this reaction? Give a reason. A reason, we are saying this, we are going to use P. Why are we using P? Because it's a reaction of a strong acid and a weak base. So you are able to say that, and you are given 2 marks for doing that. And as I conclude towards the end of our lesson, you are able to get that, and it gives you everything that we're having. And then the last question that I wanted us to do, when I look at time, we are almost out of time. When 0.01 moles of dilute sulfuric acid, so we're given the number of moles of sulfuric acid, is mixed with 0.24 moles of potassium hydroxide. So you can see this type of question almost always there. The KOH, the total volume of the final solution is 0.2. I think we came across a question like this. So even in June it was there. That is our reaction. We have 2 KOH reacting with sulfuric acid to form that potassium sulfate plus water. 2 water molecules as what is meant by a dilute acid. That definition that we talked about, we said we have a small number or less number of moles in proportion, less number of moles of acid in proportion to the volume of water, in proportion to the volume of water. So you are able to write that, and you get your 2 marks in full. You write that, guys. We have emphasized that throughout this lesson. I hope you are ready for it. Calculate the pH of the final solution. You can see now, again, we're saying of the final solution. So you can't just take a calculator and say pH equals to minus log. No, there is some working out to do. Remember, initially we're given you were given 0.01 here moles of dilute sulfuric acid is mixed with 0.024 moles of potassium hydroxide, and the total volume was that one. So this is what you were given, and this is the expectation that is expected of you. The first thing is to remember the equations. We said is 2 KOH plus sulfuric acid, because sulfuric acid is a diprotic, and then it forms that salt K2SO4 plus water. Now, if you check, you have now, you can say number of moles of KOH that has reacted. So you can use that because we are given number of moles of sulfuric acid. So you know this one is 0.01. But the mole ratio is that for KOH, you must multiply this by 2. So to get the number of moles of KOH, you multiply the number of moles of sulfuric acid by 2, which is what we're given. That's what we have done. So we are saying the number of moles of potassium hydroxide that we have is 0.02. And then you are saying now, how much is in excess? Remember, they are saying that we had 0.024 at the end. Then at the end, what is in excess is the difference. Now, they used one and the one that we had original. Original with 0.024 was subtracting what reacted, because it's reacted. What is left is number of moles of KOH now. So we can take that and calculate the concentration of OH minus, which in this case it will be number of moles of KOH divided by volume. Sorry, we're taking this route because we're not given the volume of sulfuric acid, but we're given the volume of OH minus. Hence, we can use that number of moles of KOH, we divide by the volume of OH minus, we get 0.02 moles per cubic decimeter, which is the concentration of the base. Now, you know what to do. These are the options as I conclude. The options, when you have the concentration of OH minus, and you want to calculate pH, you can simply say pH equals to minus log the concentration of H3O plus. Remember the ionization constant of water, it says that concentration of H3O plus is the same as 1 times 10 to the power of minus 14 divided by concentration of OH minus, which in this case is 0.02. So you can put that in your calculator and then you will be able to get your 12.3. And then if I can just do it to confirm it with you, that we're having minus log, and then we are having our 1 times 10 to the power of 1 times 10 to the power of minus 14, which is our Kw, divided by the concentration of a base, which is 0.02. Then we close our bracket. Then we know that we are done, and then we are able to get our answer there at the end of the day. And then, or else you can use that method of saying minus log, and then you use that concentration of H3O plus that you got, which is 5 times 10 to the power of minus 3. Power of minus 3 equals 2, and then you're able to get your final answer, which in this case they got 12.3, and then you can use that, or you can use the pH plus pOH equals to 14. So you can calculate the pOH using that 0.02, which is minus log of 0.02. Then you get your answer. I think it's 1.698. Then you subtract 14 there because you're saying pH. You're saying pH plus pOH equals to 14. And then after calculating the concentration, and then you're able to that, and then you will get that your pH will be equals to 12.3. So you do that, all these methods, you will be able to get your correct answer. And I hope you have done this and you have enjoyed our lesson, and you won't be afraid of the questions that says to you, calculate the pH of the final solution of the original solution. So know where the question is asked. And this is stoichiometric equation. You can check that is there to stay. Almost every question now we are finding stoichiometry. So you must get used to it and do as many problems as you can. As always, I would like to finish by this way that says anyone who has never made a mistake has never tried anything new. So don't be afraid to make mistakes because you are learning. As you make those mistakes, you are learning. But don't make mistakes in the exam. Make them now before exams because you are practicing now, and allow yourself to ask questions, to look at the memorandums. You are even making guidelines, ensure that you have all the question papers from all the 9 provinces in the country, and you practice them and you prepare yourself. Without wasting time, till we see you next time. Goodbye.